We're solving problem 23 from the 2022 F equals MA exam B. A mass attached to a spring is performing simple harmonic motion with velocity v of t and acceleration a of t. Which of the following could be a graph of the curve v of t, comma a of t over a complete oscillation? And we have a lot of different shapes for the answer choices this exam gives us. So to start, a mass attached to a string, we can just kind of draw that already. So if we have a spring right here with spring constant k and a mass say m here, well, what this problem is saying is that since it's oscillating and performing simple harmonic motion, the velocity is going to go this way, but the acceleration is going to go this way because that's when it bounces back and forth. So for spring constants or springs, we get that the energy for simple harmonic motion is 1/2 mv squared, that's our energy in joules, plus 1/2 times the spring constant x squared, where in this case our acceleration is equal to negative times omega, which is basically just the oscillations, squared times x. We therefore solve by dividing both sides by omega squared. X is equal to a over negative omega squared. We can then plug this value of x into our energy equation and square it to get that energy is equal to 1/2 mv squared plus 1/2 k a squared over omega to the power of 4. And we can just rewrite all of this in simpler terms. We know that this is just basically k a squared over 2 times omega to the power of 4. And we want to divide both sides by e in this case to set that equal to 1 to actually find something of use that we can use. So this becomes 1 equals 1. I'm not doing the one thing because it's like you want to format it in a certain way. So v squared mv squared 2e, and then we add the k a squared over 2 omega to the power of 4 times e, but we want the velocity and acceleration in one equation. So what we do for these fraction is, say this one, mv squared, we can divide the denominator by m, and that results in m multiplying in the denominator. So if we format it like this, where the same thing we do here, this is the denominator now becomes 2 omega to the power 4 times e times the k spring constant. We realize that this is the equation of an ellipse with variables v and a. So we look from the answer choices and see that C is the only ellipse answer choice. So we can then denote that C is our answer for this problem.